Right, so we're going to look at discrete random variables. We're going to look at some basic probability, but we need to understand some of the conventions surrounding how we set up probability problems. We've dealt with this sort of stuff before. You've dealt with this probability in year 10, year 9, but we're going to look at really formalising the way that we go about representing and calculating these probabilities. So P represents the probability that, the capital that represents, so the probability that the random variable has a value of whatever. Does that make sense? So if you can see here, it'll often come as Px equals some number or some value. If I was doing this problem here, what's the first thing I should do? Let x be the, capital X be the number of heads. Cool? So what I'm really saying here is that I want P x equals 0. Now at this point here, there are different techniques to use, but we're not going to use them for now. We're going to go back to a technique that we've learned in year 10 to deal with probability. How do we deal with probability? Multi-step probability here. Yep, use a tree, correct? So you draw our tree. What would be the branches of our tree?
Heads and tails.
Yep, heads and tails. What do I do now?
Count the last outcomes.
Because these are equally likely, I don't need to do anything else, but if they weren't, I would have to put a probability on each one, wouldn't I? You happy with that? But in this case, I don't need to do that. Identify what in this scenario? What am I looking for? Branches that have 0 heads. Does the top branch have 0 heads? No, 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 yes, okay. That equals, now because I'm dealing with equiprobability events, I don't need to do that, but I'm going to do it anyway. I'm going to do the calculation. It would be 1/2 times 1/2, which equals 1 on 4. So the probability that x equals 0 is equal to 1 on 4. Are we happy with that? I'm going to rub this tree diagram out in a second because I'm going to replace it with something else. No, no, no. You still have to use your tree diagram for now. No, it's only 2 options anyway. So it's going to be x complete the table for me, please. This was 1 on 4. You'll need to use your tree diagram. What am I asking you in that table? The next one is?
2 on 4, 1 on 3.
Yeah, but what am I asking here? What's this mean?
1 head.
Yeah, what's 1 head? So I want the probability that I get? 1 head. What's the next one mean? The probability that I get? 2 heads. Clear with that? So how many of these options have 1 head? 2, so it'd be 2 over 4 or? 1 over 2. And the last one? How do you know that that represents a probability? This is called a distribution. How do you know this represents a probability distribution? I could remove this and you should be able to tell me that represents a probability. Just by looking at that, you could tell me that's a probability distribution. How? They all match up. Not necessarily. I could give you one that looks like this.
Put all, the atoms together.
Is that a probability distribution function? Is that probability distribution? Or not? Why not? Ah, very good. So how do we check if we have a probability distribution?
After the fractions.
Yep, so the sum, how do we write? Sum of px equals x must equal 1. Does that make sense? The probability of the entire collection of values must be equal to?
So is that sum?
Yep. Does that make sense or not? So what's the probability that Ryan passes maths and the probability that Ryan doesn't pass math added together? 1, correct? There's only 2 options there. Around the back. Oh. Just around the back, stop, just around the back. What's the probability that the day is rainy added with the day is not rainy? 1. So if you have the probability of all the total events, it must be equal to 1. How do we represent something that's never going to happen? The probability is 0. What's the probability of something that definitely is going to happen? 1. You're going to do question 1 and 2. You've got everything you need to solve these. In question 1, you're just setting up your notation and solving for probabilities. You will need to draw some trees. And in question 2, you're simply checking if the tables are probability distributions or not.